Hi guys, so welcome back. So here we'll discuss about the dimensional analysis. So what is the need for a dimensional analysis? So why do we need the dimensional analysis? Because here we have been known that each physical quantities will have its own units, right? So we know those units or fundamental dimensions for fundamental quantities and secondary dimensions for the derived quantities. So based on few physical parameters, they will be having the units. So those units we're going to derive them to the fundamental dimensions because these dimensions are alone is being used to derive an expression. So that's what this dimensional analysis actually means to. As we know, this fundamental dimensions or fundamental quantities or mass, length and time, MLT. So this is like a fundamental dimensions that you came across, right? So the derived or something which has been derived from other physical quantities like the force, pressure, energy, power, velocity, acceleration. These are being derived from the physical parameter units of a physical parameters. Okay, so these are derived physical quantities based on fundamentals. So again, if you see the units are in different alphabets, right? So it keeps varying, right? So but here we can see all these been grouped under these mass, length and time. So we've been deriving it to the fundamental quantities. That's why I call it as a derived quantities. These are simple SI units of these physical parameters or physical quantities. So as we know, we have a simple example: force equal to mass into acceleration. So mass will be in terms of m. So we know the unit for force will be Newton, but here we're gonna derive it to the we're gonna do it to the derived quantities. For mass, the dimension will be m. Acceleration is meter per second square. So for meter it is in terms of distance, so L. Second square, so meter per second square, so t power minus 2 because it's been under numerator. So we're going to take it to the it's on the denominator. We're going to take it to the numerator, so it comes minus 2. So for second we have a time, so m and t power minus 2 is a derived quantity for the force. So secondary dimensional derived quantities, they are those quantities which possess more than one fundamental dimensions. So these are fundamental like MLT that has only one, so when it comes more than one, probably it is been derived from these physical quantities. For example, velocity is denoted by distance per unit time. So distance meter per second, so L by T. So these are denominator, so to take it to numerator, L T power minus 1. So this conversion is also basic conversion will come across. So acceleration is denoted by distance per unit time square, so meter per second square, so L T power minus 2. So these are few derived quantities. So these are few flow characteristics on their units and their derived dimensions. So geometrical characters, length, area, volume, kinematics, so only based on the motion. So discharge, acceleration, velocity and time, these are kinematic because it doesn't have some force. Dynamics, which include forces also like mass, force, pressure, energy, power. So this will be the dynamic characteristics. So kg, so mass, m. So for force, Newton, so Newton equal to mass into acceleration. So kilogram for mass, kg, acceleration meter per second square. So we're gonna derive it to the derived quantity. So for kg, m. For meter, length L. Per second square, so t power minus 2. This has been derived. So for again pressure is in terms of Pascal or Newton per meter square. Okay, so for Newton we know ml t power minus 2 divided by minus 2. L power minus 2. So L divided by L power minus 2, it gets cancels, and M L power minus 1 T power minus 2. If you put them on your notes, so what did I say, you can able to easily identify these things, right? So these are simplified. Because so why do we why do we actually studying these things is that in dimensional analysis we're going to use these dimensions for these physical parameters. Okay, so not going to substitute these SI units, we're going to substitute the dimensions. So that's why it's called as a dimensional analysis. Based on this dimension, we're going to analyze and derive an expression. So it is very important. It's a basic, so and also very simple and easy to understand and easy to score good marks in your university exams. Right. So here I have attached a few more physical quantities. So this has been derived from this for these physical quantities. For force, so Newton, weight again it's a Newton, specific weight again it's a Newton per specific weight is Newton per meter cube. So again it comes in this way, so L by meter cube per meter cube, so L power minus 1 minus 2 into L power 3, so it gets cancelled and will become L power minus 2, so Newton per meter cube. So density kilogram per meter cube, so kilogram mass per meter cube, so L power minus 3. So same ways for each and every parameter. So if you are clear with these dimension alone, so this will be much more enough to solve and problems on easily to score 13 of 16 marks. Okay, so don't muck up these things, just put the unit and derive it to this derived fundamental equation. Okay, so hope don't just muck up, you go through all these units. So for example, if you come across power, so you know the unit of power, so it will be in terms of watts. So if it's watts, then you know, so Newton meter per second, so force into velocity. Okay, so for force we have derived meter per second. So again we're going, if you simplify all those things, we can able to get M L power 2 T power minus 3. Okay, so it's like a work done. So that's why. Okay, so thank you guys. So